only halfway through the morning, and what I want to do is move on to our next speaker, who's already taken the podium. What an ambitious guy. Sam Snider-Held is from MediaMonks in New York City. Sam is a real-time VR, AR creative technologist working at a global creative digital production company, MediaMonks. He focuses on the intersection of AR, VR, AI, and creativity. And as a CT, he brings the most creative and futuristic projects come to life by providing the glue between sales, creative, and development. Sam has worked on VR and AR projects for Google, GE, Lenovo, World Wildlife Fund, including the world's biggest ever public AR experience, Into the Wild. Sam has a master's degree in design and technology from Parsons and an undergraduate degree in philosophy. In his spare time, I don't know if you get into this, Sam loves hacking side projects together, reading science fiction, and writing about all things technology. I'm sure he's proud that he wrote that into his bio so I could bring it up today. Sam is going to talk about neural enhanced creativity, how machine learning can evolve the creative process. And almost every day we hear about the latest in AI trends and how it affects big industries like auto, online content, healthcare. But what about the creative industry itself? It's not just technology. What does the future look like when machine learning tools learn from artists and designers? And we'll let Sam tell you about that. A round of applause for Sam Snider-Held.
Thank you very much. All right, here we go. Okay, so thank you for the introduction. Like you said, my name is Sam Snider-Held, and I am a creative technologist at MediaMonks. We are a creative global production partner. That basically means we make anything from virtual reality to augmented reality to television commercials to native apps, websites, installations. Anything that's digital and you want us to make it for you, we'll make it for you. And I also work in our R&D wing. We call it MediaMonks Labs. And this is our mad science division, where it's our job to look at new technologies and how do we incorporate them into our clients' needs. So this is a lot of cutting edge AR, VR, and machine learning most recently. To give you kind of a sort of global view of what we do, I'm gonna play our latest mixtape. So.
You feel that? Power.
Let's take it now to meet the squid. The squid.
Oh, I'm pushing him down.
I did not expect that.
Time has come to explore beyond our known horizons.
This is Colonel Sanders with Mission Control.
So yeah, I always forget to mention that we also can make robotic octopuses if that's something you're into. Literally, the sky's the limit. If you need it, we'll figure it out. And so this talk is called Neural Enhanced Creativity, How Machine Learning Can Evolve the Creative Process. And so the theme for this weekend is creative growth. So what I'm going to try to do is show you all the different ways that we can use machine learning to enhance the creative process with a number of different types of algorithms. It might be a little bit techy, but the goal here is mostly inspirational, and I really aim to hopefully blow your mind by the end of it. So we'll just take it slow and see how it goes. So before I get into that, I like to kind of do this talk about what is machine learning. So how many people think that this is machine learning? I mean, so that's something we see a lot when people are talking about this in the blogosphere or on the news. But the reality is my day-to-day looks more and more like this, where I wait for hours while that arrow gets to the right hand of the screen, and I'm hoping that the numbers on the right go down slowly. And the reason I give this talk is you see a lot of stuff like this, where we talk about AI a lot. And machine learning is definitely a subset of artificial intelligence. A lot of what you hear about are new machine learning algorithms. But when you see a title like this, MIT scientists create a psychopath AI, it's really hard for us as human beings and language users not to attribute some sort of agency behind that algorithm, some sort of thinking thing that has feelings and is making decisions. But what we're going to talk about is nothing like that. Really what you should do when you see something like this is swap out AI with engineers created an algorithm to do this sort of thing. So what we're going to talk about today is not really AI. These are just advanced algorithms that can learn. And what's really interesting about these is that we're going to be able to do things that we couldn't normally program with standard top-down writing code. So one way, this is like really oversimplifying it, but one way to think about it is that machine learning gives computers the ability to generate models about the world by showing it lots and lots of samples of whatever that world is, like 10,000, 100,000, a million samples. So you show it 100,000 pictures of cars, train it, and then after a while, you can show it a picture that has cars in it, and it can tell you where all those cars are. And then more recently, similar but different, you can show it lots of pictures of something, for instance, a cat, or lots of pictures of cats, and it will be able to generate new cats, cats that aren't in the data set, cats that it's never seen before, but images that kind of visualize all the different catness forms there are. So I'm going to get into some of the current creative uses that we're seeing. It's very experimental in these early stages. I use this as the background because this is the first painting created by an AI that was sold at Christie's for $400,000 or more. But really, this is just an artist that took off-the-shelf code and then supplied a bunch of portrait paintings to it, and he was $400,000 cheaper. And so you might hear a little bit of jealousy in my voice for that. But we'll go into where this all kind of started in terms of using machine learning for creativity. You might have all seen this. This is Deep Dream. And this is kind of the first instance where researchers were starting to say, what if instead of every time I'm like looking through an image, whenever I see something that looks like an eye, I make it more like an eye. And that's where you start to see all these DMT type sort of hallucinations. And it's just the machine learning algorithm getting really good at recognizing things and then making them more and more like that. And then it wasn't long until they started to take similar approaches to that and do really cool, useful things where this is style transfer, and we've probably all seen this, but I have this cool landscape photo that I took on my vacation, and I want it to look like a picture from Edvard Munch. And so I run it through an algorithm, and voila, I have a Edvard Munch style painting that looks like my vacation photo. Going further, we have Google experimenting with a lot of tools like this. This is a tool, but it's kind of more of an experiment because in my mind, it's not super useful. One of our designers or artists probably wouldn't really use this. But what you see here is the ability of the user to draw a crappy dolphin, and then the system understands that I'm trying to draw a crappy dolphin, and then will give me variations of better dolphins. This is a classification task. So you could start to see how we might use something like this when we're creating design work for clients or something like that. This is another big example. I showed you pictures of cats, and those cat pictures were of resolution of, I believe, 200 or so pixels by 200 pixels. These are all 1024 by 1024 pixels. And so what we're seeing, this is StyleGAN, this is from NVIDIA, and it's the ability of these machines to generate almost infinite interpolations of this data. So it could just continue generating unique faces. None of these faces are in the data set. These are things that the algorithm can generate by itself. So you can imagine that instead of giving it faces, I gave it cars, we could just generate 10,000 variations of cars and show it to a client or something like that. Or if you wanted to go more artistic, instead of showing it cars or houses or people, we showed it paintings. And then we have something like this, which is a progressive growing of GAN, a different type of algorithm, but similar, in which the artist showed it 10,000 pictures of Renaissance landscapes. And so it generates unique landscapes. This is actually a tool that Adobe just announced about like 2 weeks ago that they're going to put into their After Effects program. This is really interesting and really useful because it's basically cutting out things that you don't want in the video. So if you don't want tourists in this video or flagpoles, you can say, take this section and then repaint it. And it does it on the fly in almost real time. So you can imagine, we have guys do this at our company, and it takes them hours, right? But now we can do it with machine in a number of minutes. So that is really going to enable our workflows to be much faster. This is another NVIDIA one that they announced about last month. This is called GoGAN. And this is really interesting because it shows you how we can work together with a machine learning algorithm. And so on the left is like an MS Paint interface, and you have your classic like paintbrush and fill tools. And then the machine learning algorithm will interpret that composition and make it look much nicer. And you can see down at the bottom that you have all these different options, so that if I fill this in with red, that means flowers. Or if I fill it in with green, that is grass. And it can do this in real time. But it's not just visual. This was a Google Doodle, I think 2 weeks ago, in which if you click it, the algorithm will generate music that sounds like Bach for infinity if you wanted it to. So you can see it doing lots of stuff within music too. And then at the other end of the spectrum, if you wanted to see what Steve Buscemi's face on Jennifer Lawrence looked like, you can do that too. So if you think the internet is weird now, it's going to get a whole lot weirder. So that's kind of just showing you where all these people are like looking at this stuff and trying to figure out how we would use this. We're really at the early stages with a lot of machine learning stuff. And it's up to people like yourselves to kind of figure out how am I going to use this technology to make my needs easier and make my work more productive. I've split this up into kind of two sections, VR-related work and then standard two-dimensional illustration and animation work, because these are all things that we do on a daily basis. And we're just trying to figure out what's this stuff going to look like in 5 years from now. So we'll start off with the VR experiments. How many people have tried something like Tilt Brush here? Well, if you haven't, we have Masterpiece VR down there. This is another 3D VR creation tool. And if you haven't tried these, what's really magical about this is it really lets you imagine what the near future of creativity is going to be like, where anything that you can think of, you can make in front of you and feels real. So this is a very powerful tool. And
The shuttle from Airport Authority will depart in 5 minutes. Please clear the path and stay behind the yellow line.
with these is that they are still steeped in 30 years of screen and mouse design. But what's infuriating about that is when we're in VR, everything else is natural, and then we have to go back into these 2D screens. And you know what? It looks like Iron Man. It's really not the most, it kind of takes you out of the creative, sort of lucid dreaming creativity that we have with VR. So my instinct is that we can use machine learning to make this much easier because, like I said, machine learning requires lots and lots of data. But when you jump into a VR environment, essentially everything you're doing is being turned into data. So it makes it very, a healthy place to apply machine learning to. So we're going to start with different forms of gesture control. So here, this is like the first experiment that we did, that if I wanted to draw a primitive sphere, I would just have to draw a circle, and then a sphere would pop into that circle with the exact same scale. And then you see that with a square and a cube too. We iterated on this interface to make it a little bit more manageable. So I'm drawing a tree here, and then all of a sudden I can place as many trees as I want. You're gonna see me draw a house diagram here. Right? And then, you can basically do as many types of objects as you want. This is very close to what we were seeing with the Google Auto Draw, except for it's in VR and in 3D now. So if you wanted to draw a bus and place multiple buses in there, you could do that. So this is pretty cool, but at the end of the day, it's really not that much more useful than a speech-based sort of implementation where I say, give me a house. So we wanted to really think about if we could sort of evolve this. And like I said, the computer has the ability to really watch everything that I'm doing. So could we get it to a point where it could actually anticipate what I wanted to do and then give me that asset right before I need to place it? So this is where we get into imitation learning or behavioral cloning, as it's sometimes called. So imagine a system like this where I am walking around and I'm placing objects in this VR environment. And as I'm doing this, we're recording all of my actions so that it's broken down into something like this. Every time Sam saw this, he placed a tree. Every time he saw this, he placed a bush. Every time he saw this, he placed grass. If we could train a sort of neural network to basically be watching this and try to recognize these patterns, we could start to have it anticipate what you're doing. You can think of it kind of like a surgeon's assistant in the ER, where the doctor never has to say what they need. They can just put out their hand and the surgeon assistant will just put it in there. But this is where it gets kind of crazy, because if you can accurately train a neural network to kind of envision what you're going to do before you're going to do it, then at what point do you really need you in that moment? And can we just run the clone by itself? And so here we are running a behavioral clone of me, albeit it's much slower than I would be doing this, but what you're seeing is that it's making visual decisions, so that when it sees an area where there's no trees and it thinks there should be trees, it will place a tree there. Same with grass, it sees groups of grass and it will place more and more grass. And so this is starting to get a little bit crazy. Right? This is an output of that. So it looks definitely more organized than just random placements of trees. And so we're starting to look at possibly a futuristic example of where you could, on a Friday night, go home at 5 and then just keep your clone running, and it will continue to develop that 3D scene in a way that's really similar to the way that you were doing it. But the craziness doesn't really stop there. You could actually spin up 10,000 clones of you on AWS or Google Cloud Platform and just have them complete a game for you. This is definitely very futuristic, but you can see the sort of beginnings of this in a lot of technology companies and how they do things like self-driving cars or how they teach programs to play games like StarCraft. So we see that the AI or the machine learning can help us place objects and pick objects, but can it generate objects? Our first attempt to do this was to teach it how to draw trees in a way that we wanted to do it. To simplify things, we kind of went in this sort of Japanese Zen painting sort of trees. And so here you see me drawing tree after tree after tree. Like I said, you need a lot of data, so I did draw around 1,000 trees by myself, and it did take 3 days to do. And this is what that data set looks like when you flatten it to 2D. And here is what the algorithm can come up with by itself after we've taught it to draw trees. Not exactly the same, but similar enough that we can say that it's drawing trees. And that allows us to do a lot of really cool things. Like you can tell it to draw every possible tree between two different trees. So here is a linear interpolation between trees of the top left and the top right. And this in itself is a kind of new sort of menu type of interaction where if I want to change trees, instead of going into a menu system, I can just on my Vive thumb pad kind of slide my finger across it and you get these different types of trees. And so we wanted to experiment like how this would work in a sort of drawing environment that mixes machine learning based trees and standard drawing mechanics. I've sped this up, but you can see me drawing a kind of very abstract version of a sort of Zen painting landscape. And I've also placed these VR trees, these machine learning VR trees. And after I've placed them, I can also manipulate them using machine learning to say, I don't like that tree, give me more trees. What does this tree look like, et cetera. And that allows you to draw sort of things that look like this, or this, or this. And so we started to realize that you could do a lot of really cool things in VR. And I'm sure there's, an entire industry that's based off of this, but we really got interested in these sort of illustration capabilities of this because we can see that it can start to draw things, trying to get into a way where I don't have to draw 1,000 trees over 3 days. So now I'm gonna move into the illustration experiments. I already showed you guys this from NVIDIA, but I also think this is not quite usable because the output space is very defined. It's only gonna do kind of earth porn type images. But where we want to be is a place where you as an artist can just say, I want you to help me draw forests that are in the style of charcoal. And so here we are doing this. You see here on the left, I'm just drawing very blobby forms, but on the right, it's filling in all the details. When you can create data sets like this, I'm going to show you how we create those data sets. You can also have the neural network not only help you art direct, like what we're seeing here, but it can also generate its own unique trees. So here, every frame in this animation is a unique tree that the algorithm can draw by itself. And what's interesting is that there are no samples in the data set that have 2 trees in it. So there's a lot of sort of combinations in there that the system can come up with that I would not have thought of. So how do we do this? We basically say, you pick a style. So I picked this image off of Google. And then I went into Unity, which maybe you guys are familiar with. It's a 3D gaming platform. And we placed a virtual tree in there. And then we use Unity to generate 10,000 virtual photos of this tree, something like this. And then we run those photos through style transfer with that charcoal drawing. And all of a sudden, we have dataset samples that look like this. And so when I have 10,000 samples of that, I can create these crazy sort of interactions and these new forms of creativity where we're getting all these cool animations, but also it can help me art direct. So I just say, this is the composition I want, you do your thing, and then we're going to create really cool artwork like that. So those are the illustration, but it wouldn't be too much of a step to go into animation. So I'm gonna play this video that's showing our progress over the last couple of months of how we are using these same techniques to create full-scale animations. talking about, where it's basically the same sort of process, but I'm just saying, all right, give me an oil painting. Okay, give me a charcoal painting. All right, give me watercolor. So how do we do this? Well, it's very similar. We're using Unity to synthesize all of our data, but we use motion capture. So for this one, I could have picked a hip hop dance, but I picked modern sort of jazz dancing. So I'm able to generate thousands of frames of this in sequence. And when you use this type of data set, you can use things like recurrent neural networks or variational autoencoders. And these will allow you to generate new sort of dance sequences or copy dance sequences. So that's what you're seeing here. A lot of these are synthesized sequences that don't really belong together, but are being synthesized together. You can also do essentially an autocomplete feature where you give it one pose and then it can complete dance sequences with a number of variations to it. And when you put all those technologies into an interface, you get something like this, where I just draw a very simple gesture, here a triangle, and then it will give me a pose and a dance sequence that looks as much like that as possible. Here's another example of this being in a T shape. And so this is a very expressive way of creating art, where I'm not going through menus, I'm not using a lot of UI, I'm really just using a paintbrush and doing stuff like this. But if we wanted to have more control, you could have more of a standardized interface like here. So here I draw a similar gesture, and then on the right you see it give me all these poses that look like that gesture, and I can see what sequence follows that. Then I can pick one. This one's a little slow, but what you're going to see is that I'm going to continue to construct this animation sequence with very little effort on my part. Most of the work is being done by the machine learning algorithm, and I'm really just doing the art direction. So now I want a pose that's kind of standing. And then once the machine learning algorithm has all of these, it can stitch them together. So that's stitching it together. And here's the sort of output of them stitched together. And so once we have this sort of animation on the left, we can then run that through a style transfer. So every frame through a style transfer. And then you get something like this. So the work I did for making something like this was literally drawing 5 different lines. And then we have an animation like this. Style transfer takes a long time. You can also use other forms of GANs, and it's all a bit of an engineering trade-off for how long do you want to train something for, or how long do you want it to take it to render out. You could do this in a way where it doesn't, to make something like this, it has to render overnight, but you could do it in a way where it renders instantaneously. It's just engineering trade-offs. So I'm hoping by now that you can kind of get an understanding that machine learning can be applied to creative tasks. A lot of people will say that, the AI is getting really good, but it's never going to take over art. But I think that's kind of a misdirection. We're not going to use these things to replace us necessarily. It's going to be more akin to like Photoshop, where imagine designers in the 60s, how they had to make print ads in illustrations. It was much different than how we do it now, where if I mess up, I can just undo it. And now we're going to have these creative applications that can help us generate a lot of possibilities, a lot of creative ideas with minimal effort, meaning that we can do a lot more. So in this, I've showed you that we could use it for gesture control, behavior cloning and imitation learning, automatic and assisted illustration, automatic and assisted animation. And so we're getting into this question of what could the future look like? And so yeah, you do see a lot of this where we think it's going to be us versus the machines, and seems like I froze, but we're almost done anyway. Let's see. Oh, but yeah, I don't know why it's freezing. But really, what we should be thinking about is that we're moving into this age where our creative tools, we're designing creative tools that can be taught or that can learn. And so it's just a new sort of smarter tool, and it's more human-centric. So I don't think it's going to be like this, they took our jobs. It's going to be more like, they took our jobs, and we can go on vacation and still get paid. So yeah, that's pretty much it. If you want to learn more about what I do and what we do at MediaMonks, you can look at this link. They'll show some of our blog posts and stuff like that. I think I'm like seriously under time, so we have a lot of time for questions if you guys have them. We have one over there.
Thanks a lot, Sam. It was wonderful. And yes, we do have time for questions. And we'll have, Drew, is there a microphone for you that we can steal from the stage? Let's take this one. Let's take yellow. We do have time for questions. Raise your hand nice and high. There we go. We got a first one to lead us off. And
Hi, Sam. I was wondering how would a creative growth like this lead to something like thought? Would these machines be capable of thought because you're feeding them so much of information?
You're saying how these things have thought? Is that the question?
No, would they have the capability of thought?
The capability of thought.
Yeah.
So this is where we get very philosophical. I don't know, but if we look at the math of how these generative adversarial networks work, or how an autoencoder works, where if you train an autoencoder on pictures of cats and dogs, right, it will learn a mathematical representation of that. So you can say to it, take this picture of a cat, take this plus this picture of a dog, minus the tail of this picture, and you can describe that mathematically. And when you understand how that works mathematically, and you think to yourself, is that how my brain does it? It's a really kind of mind-blowing sort of sense. So, you know, we get into questions of how are we capable of thought? We don't know yet a lot of what a conscious experience is. So I don't really have a good answer for you. I can show you that these things can make art that are seemingly combinations of everything it's always ever seen, but then we start to think about, well, isn't that what I'm doing when I'm creating something? I don't know. It's a philosophical question. It's not really a developing or engineering question, you know?
True. One more question is that if these cats, you fed them cats, so what if you give them something abstract along with the cats? How does it deal with that?
Right, so one of the things that's interesting in my research of machine learning is that it's difficult for a machine learning algorithm to converge on a pattern if there is no pattern, right? So if you send it lots of images of random noise, it's not going to be able to develop a model of that because there's no pattern in there. So it's just going to stop training essentially and just not get any better. If those abstract paintings have some form of non-abstractness in them, which I guess is besides the point, I don't know. But if you think about, like, if we send it millions of paintings of Jackson Pollock, right? These are abstract paintings, yet they have internal cohesion. They have patterns in there. So it could probably learn to do that. Is it going to be the next Jackson Pollock? Probably not, because it's just not what these things are doing. They're not they have no agency. They're just doing what I tell it to do. So I'm surprised if it ever comes up with something that I didn't expect it to. So if I show it pictures of cats, it's never going to come up with an alligator, right? So,
Thank you.
that leaves me feeling better about machines taking over my job.
yeah.
Absolutely. Next question, hand up high. There we go.
Thanks for sharing. This is really cool. It's neat to see the technology in action. My question is that if we're pulling from media that we know is already predominantly, like to use your example of the art, right? It's predominantly made by men, predominantly white men, right? If we're pulling from those examples, are we going to end up with something that's more diverse or less diverse? And if we're looking at the current media landscape that is lacking in diversity, do you see this as an opportunity for more diversity or for less?
I don't know. If you are pulling from public data sets, you're probably going to run into this diversity issue. But what we saw in the illustration, I wasn't pulling from these data sets. I was synthesizing my own data sets. People in machine learning and in general will tell you that the biggest problem, what it's all about, is getting the data. All of this is about how much data you have and how good is that data. If you're not careful, you will skew your data. So machines, these things are basically just doing what we already do, but on a computer scale. So I'm not going to tell you that somebody won't create sexist AI bots. They probably will. You know, Steve Buscemi case, the first instance of people doing that was for pornography, so they could put Scarlett Johansson's face on whatever porn star that they wanted to. So obviously it's already there. It's like the first instance that people use with these things. So we always have to be diligent in data science in terms of sort of the gender bias or the sort of racial bias. It's a huge problem, but as more and more engineers go into it and they have that diversity, they will filter in those data sets. But it's not the machine learning algorithm that's doing this, it's the engineers.
Yeah, true. I've read something recently that the gambling industry is also leading a lot of that machine learning and artificial intelligence because they have a lot more to win or lose, right? More questions from the audience. Up front here, Drew.
Just a quick question. The object creation and the auto animation that you did in Unity, was that just using a plugin, or is that something you guys created with a plugin?
No, so to generate, to synthesize data, it's quite basic Unity things where you just put a camera there and you rotate it around the object, and then every frame you take a picture. The machine learning was done all in Keras, which is on top of TensorFlow, that we network with a backend with. Unity is doing a lot of machine learning work, so that you can run TensorFlow in Unity, I think, these days. And they're also, I believe, working on a data synthesis plugin. But you can do all this stuff integrated with Unity, not using plugins, and they're very simple to write.
Using Keras, you said.
So yeah, it was done. I work mostly in Keras because Keras is a very high-level language and easier to get into if you're not into machine learning. By the way, you don't have to go to a computer science program to learn all this. I learned all this on YouTube and Reddit. So it's one of the most interesting fields to be in, that it's high-tech and very open. And so Keras is a good example of that, where it's very easy. You can write these algorithms in like 30 lines of code.
Thanks.
Any other questions from the audience? Put your hand up high and we'll come to you. Anyone else? Last call? All right, big round of applause for Sam Snider-Held, everyone. Thank you very much. So we are going to take a short break so we can all get something to eat, but be sure to check out all of the exhibitors in the interactive zone. And we'll meet back here at 12:45 for our next talk, Manuel Lima from Google. But a reminder that there are studio tours that you can register for back at the registration desk. All these tours run tomorrow afternoon at 4 p.m. sharp. Tour A will visit Artscape Launchpad just across the street. Tour B will visit Cisco Canada Innovation Center. Tour C, Autodesk Research Center. And Tour D will visit the Goth Institute. Go back and check those out, and we'll see you back here at 12:45 when you're nice and fed. Thank you very much.